Google just quietly dropped its smartest model ever, which other companies say the same, so I just ignored it. But I went through the details. What I found stopped me so cold. This model cracked a math problem that scientists has been trying to resolve it for over 10 years, and this model just cracked it overnight. Not only that, it proved that some theories that scientists believed for more than 10 years it was true, the model said it's wrong and it proved it. This is just one out of 18 breakthroughs that this model provided and destroyed all those scientific challenges in a moment, and I believe this should be the biggest AI outcome within 2026. In this video, I'm going to tell you why and how you can access this model right now. This is new deep think mode of Gemini model. Let's check it out. The term deep think by itself is not new. You might have heard that beyond just Gemini model, but this new evolved version of deep think for Gemini has a lot of stuff to say to us. Just check out the initial benchmark metrics you're sharing the screen. So here in the reasoning and knowledge, just considering Gemini 3 Deep Think compared to 3 Pro, and glad to see Claude Opus 4.6 has been used as benchmark here because this is the best Claude model so far that I'm recording this video right now. And then GPT 5.2. And look at just the performance. It got almost 2 times, even more than 2 times performance over just Gemini 3 by adding this deep think mode. Same here for humanities last exam, which is a bunch of multidisciplinary hard challenges that needs academic reasoning without using any tool. Usually models perform very low, so having a score 48.4 by itself is really considerable. Other thing for multimodal understanding, again, the best compared to rest of the benchmark models, but not just significant difference compared to Gemini 3 Pro. So again, better, but multimodal capabilities maybe is not something that deep think mode was really focusing on. And Codeforce, which is a global exam for programmers that they need to sit down and solve the most challenging algorithmic questions, and having the ELO score of 3,455 by a model is almost close to the top first 10, maybe top 8, the most advanced human programmer in the world that can really tackle the toughest algorithmic challenges. So having that score by Gemini 3 Deep Think is really impressive. Now with these enormous improvements on the models, specifically Gemini and here Deep Think, this is a great opportunity for having AI to be able to do autonomous research and come up with discoveries. And this is what really DeepMind team did. So we initially at phase 1, we had these models for helping us in doing some data processing and potentially doing some pattern recognition. We were creating agents to do automations, but moving beyond, we were able to have these models develop codes and implement codes and refine the codes and do some further iterations of processing and refinement by themselves. But now at phase 3, we are doing actually reasoning and discovery by models. And why this was challenging, because doing truly reasoning in mathematical or research-based, not just Olympiad-based domains, you really need to have that out-of-box thinking capability, making sure that you can think multidisciplinary and come up with something that you might have never seen or has not been resolved, namely some breakthroughs that I'm going to talk about that the scientists were trying to resolve that for more than decades, but this new model did, and I'm going to share with you how. Previous versions of Gemini Deep Think mode, which was almost last year around June, July, they were able to actually test the model to achieve gold medal level in International Math Olympiads 2025. So that was really the biggest breakthrough that announced last year. Not only that, in some physics, chemistry Olympiads 2025, the model was able to get some gold medals, which is absolutely astonishing. But now we are focusing the direction towards beyond just Olympiad level math competitions. We're going to focus on research level math challenges, which is much more challenging because of the fact that the model needs to be niche on a specific domain, be able to think out of the box, connect the dots to other fields within, let's say, math, and come up with a new discovery. This is not really feasible with current models because they have been trained with vast amount of data, so they have this holistic view of everything, but they want to connect the dots on something specifically unique, unseen, and niche. They might hallucinate, overlook, and they're not able to really think out of the box. We have seen on news that Claude OpenAI companies, they still keep hiring people for specific fields that they believe they cannot really automate them with AI agents because agents cannot think out of box. But when I was reading through the details of this deep think mode of Gemini 3, which just got released last week, it truly is changing the game. What DeepMind team did for leveraging deep think mode in research, they internally created a new research agent that it is able to iteratively go through different sources of information, find some hypotheses, verify them, fix itself, or even just confess if it cannot resolve, which is a unique outcome by itself, and iteratively go back and revise itself until it come up with an outcome which is verifiable by human researchers. And this was really the game-changing moment that came up with all those breakthroughs that are going to go through the details of that shortly, which was enabled by this specific agentic research that they created using this deep think mode. So with having this deep think research agent in place, they had the role of this new agent on different breakthroughs, considering that iterative refinement, that they were vibe proving through dialogue, cross-pollination, so bridging those out-of-the-box fields. Do they see that the model is capable of actually connecting the dots in different aspects of a field and come up with a new discovery? And then that adversarial review, they had this model or agent to go and read some previous research paper published, saw some flaws and shortcomings and proved that was wrong, so they contacted researchers to revise their papers. I'm going to talk about that soon. And some other theories that researchers may think it was true, this model came up with some counter examples that try to say that these counterfactual examples that I'm providing is proving that your assumption or your belief about this theory, you as a scientist, is wrong. And here's an example that prove you are wrong. And it happened. And then, last but not least, they were able to actually use this iterative research agent to develop and publish research papers end-to-end by this model or agent. This is the reference about that agentic research agent they created in DeepMind internally. They call it alithea, if I'm not mistaken or pronouncing it correctly. Again, this is just a critically iterative loop that generates, refine, come up with candidate solution, and can do it in parallel. So if you have an hypothesis, you want to test multiple things, you don't need to be just sequential. So it's going to speed up the process until you have the final outcome, which is verifiable but human. And what they showed interestingly here is that they benchmarked to see this new deep thing is better compared to the last year deep thing, which got those Olympiad medals that I just discussed. And they realized that if you follow my pointer, with the given inferencing time or the compute amount that it needed, they improved from this white line, which was last year, to all the way up, which is the score, higher score with this new deep think mode. It constantly outperformed whatever they had last time. And this star, if you question me what that is, this is that alithea research agent they created. So with the given time compute, it got the highest score even beyond just a deep think mode. So that's a proof to tell you that even when you use this new deep think model, which is an upgraded, evolved version of Gemini, you can create that iterative loop of an agent using this model to even outperform the model benchmark. As they noted in the paper, it's almost impossible for having a model that directly in one shot, in one probe, you ask something and gonna resolve it. That reiteration or the loop they just provided in the agent they created is necessary to be successful and also again outperform even the initial benchmark by just vanilla deep think mode by itself. And same thing for math basic PhD level exercise. They were able to have significant scores upgraded and again outperforming those benchmarks using these iterative agent alithea they created. They released a detailed paper on some of the breakthroughs in discovery and scientific challenges that Gemini tackled with this deep think mode and succeeded. If you're interested to know about the details, I will share the link of the paper in the video description below. But if you just check out a couple of them, which was truly impressive, I'm going to go through some of the details that I think you will find it very interesting. The first one was that they give the role of adversary or deep technical review to this deep think mode agent they created. So they said that check out this paper, and that paper was about cybersecurity and some cryptography stuff. I didn't go through the details. I'm not an expert in that field, but the idea was those researchers in that paper claimed that their solution in this given domain is one of the most secure cryptography solutions and almost impossible to break that out by a hacker. But when they give this prompt to Gemini that, hey, go, you act as a very sharp reviewer for the paper, come up with any review results, any critique that paper, and tell us if this is true or not, the AI or the agent flag that there are some edge cases due to randomness that a hacker might be able to break this solution. And in security, if you have a solution that there are some cases that your system can be broken, that's a big mistake. So they contacted the authors, and the others retracted the claim. This is something that top reviewers totally missed, and Gemini intelligence was able to capture it. Obviously, outperform human, and the original researchers approved that yes, that was a mistake, and this deep think mode is absolutely right. Another breakthrough that this deep think mode did was it was acting like a bridge builder. This is like that out-of-the-box thinking that it connected dots on two different things in the field of math, that it was able to come up with a new solution. So on the left side, we have all these discrete vectors and points in multi-dimension world, which is hard to tackle and come up with computations. But what Gemini did, it came up with some conversion formulas using some well-known theories, something that you might have never thought about it. Oh, that theory called A could be used here, but Gemini saw that, it brought it to the point and reframed that the discrete world to this continuous calculation of a sphere, and convert that calculation to a continuous energy optimization over that sphere. And why it did it? Because it realized that if I convert this discrete world to something continuous, then I can leverage some tools that has been proven by scientists in continuous calculation, which is much more smooth. That's why it used this, for example, given tool, but it couldn't use it in discrete world. So having that conversion and using the tool, it gave that ease of calculation compared to the initial domain. So that means with any discrete vectors and points in a given dimension, I can maybe decrease it all the way down to a 3D dimension of a sphere, which is going to gain significant benefits compared to the original outcome. Again, this is something that scientists totally missed. It was not even something a human could give a hint. That was all the breakthrough of this deep think mode by itself, and it is verified by human researchers that this is true and it works, and it's a new solution. Here is another one. It's called retrieving obscure knowledge. So what they did in this paper, they noted that we give this task to actually a Gemini deep think mode given a very Euclidean embedding of arbitrary graph. For example, this one, that means each node by itself can be, let's say, a network. Or imagine that these nodes are cities that you connect them with roads here. So you can see that this is totally arbitrary shape. It can be very complex given that the dimension can increase. We might, for example, add different cities between these two cities. So if we add all of those, that's going to be tough to answer this question. And what is the question? What should be the most optimized design of this graph to give us the cheapest construction for having the cities connected through the roads? This is just one example of optimization. Again, it's all about how you represent a given domain of nodes and edges that are connected together to be used for, let's say, further optimization or different type of calculations. But what this deep think mode model did is that, okay, I can leverage some other well-known theorem, like for example this distance compression algorithm, to be able to convert this to an embedding of a star graph, or better to say simplex. What is simplex? Simplex is about any geometry shape that is very balanced and nice and clean to be calculated. For example, in 2D, a simplex would be a triangle, because you can have a point in center, and with this one you can easily calculate the center to the edges or the middle of the routes that they connect in the edges. In 3D, it's gonna be different. In 4D, it's gonna be different. So with having this squeezing algorithm of having this arbitrary graph from Euclidean embedding to a star graph or simplex space embeddings, that means I am just shrinking the points. Points can be closer, they can never be far from each other, so this solution always is equal or even cheaper from the structure perspective. And having that representation of transformation would be much more feasible from calculation and cost efficiency perspective, so I can use this as a reference instead of this original demonstration. They also noted that they were able to autonomously research and publish papers all by this model, or doing some vibe coding, and some of them with collaboration of human. They have added a link of those to the reference link I'm adding in the chat, so check out the papers that are truly research, calculated and published by an AI model, and of course verified by human, which we are in an era that models are doing research and publishing by themselves. We were all talking about it gonna be coming soon, but it seems like it's already there, and we are seeing that in action. But something they noted, that they said, we are not really claiming any level 3, like a major advance, or level 4 landmark breakthrough by an AI agent. That means if we consider what these AI agents can do, research and publish, it's not really a toughest breakthrough. So if you think about different levels, level 0 is negligible novelty, minor, publishable, significant, landmark. They're not talking about the breakthrough or significance, but in publishable research level, which is 2, they had human with secondary AI input. They got some outcome. Here's a paper. They have human AI collaboration here, and they have essentially autonomous. That means just AI by itself, like this eigenweights published in 2026, with just AI model. And same thing for minor novelty or negligible novelty. So we are not in level 3 or 4 yet, or they're not claiming that yet. But honestly, I don't see them far at all. Some interesting best practices they shared in the paper was that they de-identified all the context, because they wanted to make sure that when the model see the title, the name of the research aid, it wouldn't try to refuse solving that problem, because it might recognize that as a famous open problem. So the model is smart enough thinking about the fact that, oh, this is something that no one could fix it with all researchers. I'm not going to do that. It's impossible. So they identified all those to make sure that the model wouldn't be biased towards those, and model won't refuse researchers to resolve that. The second thing they specified was scaffolding. That means instead of having all different ideas and theories and tested by the model for any given topic, they break it into multiple lemmas, so that will help the model to tackle them separately, and we can verify those separately with external theorems. And last but not least, trust but verify. So this is they saw that the AI is excellent at ideation but can hallucinate details. So human must validate final logic. So they're not relying on final results and saying that we fixed it. Everything was verified by human from the output perspective. And last but not least, what we see right now is truly a shift. If you're a researcher, a PhD student, I think right now your AI friend is going beyond just a chat interface. Now you can see AI can publish neurosimply pipelines of papers that can be really published in well-known and acceptable sources. So the shift is now you're a scientist from a potentially a solver, you focus on architecting the reasoning. Or from idea generation, the idea could be generated easily by the model, you're going to be the one to verify what this model are performing and providing as an output or breakthrough. Again, this is just really based on the current capabilities that we see, and they're evolving them, or see the involvement of those with the models and the model providers. But who knows how the future going to look like exactly, but sky's the limit, and we're all keen to see what's going to be the new future. And lastly, how we can access this model right now. Well, there are two ways. One way is you can just enable it right now, which is you have to have Google AI Ultra subscriptions. I know that potentially is among one of those expensive subscriptions, but I think the value will be paid if you're truly leveraging the model. So you can right now go ahead, enable it. It's available for anyone with having that subscription. That means when you go to the Gemini app, I have here, you will see Ultra instead of Plus, because I don't have that subscription. And if you click on the tools, you will see Deep Think added here. Again, I didn't purchase that. That's why I don't have this function added here. But if you want to use this as an API, for now, it's not there yet. So you can just express your interest as a scientist, engineer, or whoever you want to use this API. Just fill out the form. You might get early access to the API of this Deep Think mode. That was all about Gemini 3 Deep Think. I hope you found the video helpful. If yes, I would be very thankful if you consider like and share your comments and subscribe so you won't miss the next video. Thank you so much.